Okay, in this video, we're going to talk about part drawings in SolidWorks. So last time we just talked about drawings in general and the different things you have at your disposal when you do make drawings. But for here, we're going to go into more details on how to make a drawing pretty much ready for use. Okay, so I'm going to delete this little text box as we're not using it. So let me just go over this procedure once more. Gonna delete everything. So when you come here to this view palette, right, you want to refresh to see your part. And then once your part is in here, you could right click and then go to project view to get your other projections. So the way you decide how many projections you need, you want to see what sort of features you have and then what sort of thing will give you just enough information to design your part. So, like, for example, if I have these two views, do you think this view is necessary? So the way you could figure that out is, okay, this only tells me two dimensions, right? I could really get these two dimensions from this length and then this length. So in this case, this doesn't really present anything new. But one thing it does tell me is if I'm looking at, it can confirm that there's nothing on this face. Okay, so this is kind of useful, but not 100% critical. Typically, three views is really more than you need. Like, for example, if I added like another view like this, it doesn't really add anything new. Okay. Unless there's like a hidden feature that I couldn't see. Or like if I went ahead and add another view on the top, this really doesn't add anything. So I would say in this specific case, really, 2 is the minimum, 3 is maybe you need it, just so you know there's nothing, but, you could get away with 2. And sometimes drawings by default can be a little small, so, you could go ahead and change your scale if you want it to be a little bit bigger. So, if your scale is not here, you could use, a custom one, and you could just type it in. So here, it's gonna go to 1 to 1. And you kind of play around with when you actually start dimensioning it to see how much space it takes up. I'm just gonna actually delete that one just for sake of spacing. So you want to position it so that it looks nice and spacious. And you could dimension it a couple ways. In this video, we're gonna go over the ordinate dimension. So you could like right click or actually in annotations, you could do smart dimension ordinate dimension, and then you could click one side, right? And then you could click like this to see all your dimensions, and then you could do order dimension again and click one face. That's going to be your 0. So you can see that this fully defines the sketch. And sometimes maybe you would start like the 0 on the other end for this if it makes more sense to you. That way you can see the thickness more easily. So that's kind of a preference if you think about where the 0 is located for the person. Okay. And sometimes you might see like a smart dimension and just come in here and say like the thickness. But in this case, that would be duplicate. So really, this should be suffice to fully define this. So really, to dimension your part, you really want to fully define your part. And then a fully defined part in like your config when you do like your solid modeling, it'll be, you know, you'll see like the blue lines turn into black line. That's essentially the same concept. Okay, so here we're gonna add some more ordinate dimensions. So for here, you can see we add some holes, and then typically because we already know the length of this plate, you don't really need this. So this could be omitted, or you could add it in here and like add parentheses. That's what some people do. That really depends on the convention of like the place you're working at. So we're gonna go ahead and do this, something like that. And again, these are like duplicate dimensions. So maybe you could just hide it. Actually, this one is the depth of it. So you actually don't know this one. This one you know from here because you have this dimension, right? So that is given to you. So this one you could add like a parentheses in here. For example, this one right here, parentheses. So sometimes the parentheses is like repeated. That's what it means. So for these, right, you could say because these dimensions are repeated twice, sometimes you might see like a 2x here. That would be like one way of showing that you have two instances of this whole dimension here. Okay. And then you could add like a whole call out here. There's like one hole here. You could pull it. So you can see you could pull it at many different places. I typically like to just pull it somewhere that makes it look pretty. And by pretty, I mean just like nice and spaced out. So you can see these hole dimensions. What it'll tell you is one is the diameter of the hole and then the depth. So here's a 1.5-inch through hole, and then here is a 0.17, and the depth is 0.47. So notice that when I made this, I didn't make it a through hole. That's why it's showing 0.47. So I could actually open the part and try to edit this. And if I come here to my tap drill hole edit feature, I should see that this was actually a blind. So a more appropriate one would be to make it a through hole. And then that way, if I come back into my drawing here, you can see that this got updated to through all. Okay. So through all is a little bit cleaner because it doesn't make sense to do blind when it's actually a through. So that's where that would come in. And notice that all of these dimensions are to like two decimal places. If you have like very precise location, sometimes you might want to actually up it to 3. And this is in the document dimension. So it's reflective in your options, document properties, should be in dimensions. So here it's sometimes good to have it in 3, especially if you're doing more precise drawings. So that should notice that all the dimensions now reflecting 3. So when you're actually designing for manufacturing, sometimes the actual tolerance matters. And in this case, you could have something like bilateral, which could be like plus 0, minus 0. You could have like symmetric. So here we're just going to do like plus or minus 1 because maybe we want it to be in a very precise location. That's just an example, but in this actual application, it may not matter, but in some applications where the location does matter, you want to do that. And same with like the hole diameter. Let's say this is like a slip fit. You could do like a bilateral, maybe like a plus 2, minus 0. That would be like the tolerance. So it'll be above 1.5. It'll be at most 1.503 and at least 1.501. So there's like a guaranteed small gap inside the part to fit. So if I look at this assembly here and then, if I zoom in really close, you should see like a very sliver gap in between. It's a little bit hard to see, but if you zoom all the way in, there should be like a small gap here. Okay. But the point is like when you have this drawing, when you make the drawings, you want to make sure that this gap is guaranteed so that your part will actually fit correctly. Okay. So once you have dimensioned everything, we have the key dimensions, we have the key lanes, we have all the holes specified, and you have these like center marks for your hole. Sometimes, if the center mark size is not quite what you want, you could, change the mark size to your wishing. But in this case, we'll leave it as is. So that's pretty much how you would make a part drawing. And then to put the cherry on top, sometimes you may want to add in like a isometric view somewhere in the bottom. And this just kind of summarizes what the final part is. Okay. And then we also talked about like the notes. You could add notes if it's special instructions or there's like more advanced stuff that we'll get into in a different series. But for now, this should get you started in just creating a drawing to begin with. And there's like other things you could fill out here depending on the specifics of your company or whoever is doing the drawing. They might have certain ways of filling this out. So you want to see what practices they do. But at least for now, you're able to create a drawing in SolidWorks for a single part, and hopefully you can send it off and have someone manufacture for you, and then there might be some back and forth between the like machinist and the design engineer if something is unclear. So if you found this video helpful, give a like and subscribe, and I'll see you in the next one.